Welcome to the Passion for Technology podcast. In today's episode, we bring you an article readout from TQ Magazine, exploring the compelling vision of the all-electric society. For full access to the magazine, more insights, in-depth articles, and key facts, check out the show notes. Green electricity on the rise. In 2024, the demand for electrical energy has experienced its largest growth in the past 20 years, and experts predict a similar demand for 2025. The good news, more and more sustainable energies are meeting the world's energy hunger. Photovoltaics alone account for around half of this increase. The growth in global electricity demand this year and next year will be among the fastest in the past 2 decades, says Keisuke Satomori, Director for Energy Markets and Security at the International Energy Agency, IEA. The reasons are robust economic growth, severe heat waves, and the increasing prevalence of technologies powered by electricity, such as electric cars and heat pumps. Parallel to this, a rapid expansion of renewable energies can be observed. Compared to 2022, according to market analysts from McKinsey, about 50% more capacities from renewable energy sources, a total of 507 gigawatts, were installed worldwide in 2023. Their share of the global electricity supply will therefore continue to increase from an expected 30% in 2023 to 35% in 2025. Photovoltaics alone will account for about half of the increase in global electricity demand in 2024 and 2025. And together with wind energy, photovoltaics could even make up 3/4 of the increase in demand. Even more impressive are the figures from the European Union. According to Eurelectric, the Industry Association of the European Electricity Industry, 74% of the electricity generated in the EU in the first half of 2024 came from renewable and low-carbon energy sources. However, these figures also include electricity from nuclear power plants. It is encouraging to see the share of clean energy in the electricity mix continuing to rise, but this needs to happen much faster to meet international energy and climate goals, warns IEA Director Satomori. In parallel with the accelerated expansion, the efficiency of technologies used to generate energy from renewable sources is also increasing. The average efficiency of photovoltaic modules today is about 22%. By 2030, an increase to at least 25% is expected, according to the Photovoltaic Status Report published by the Association of German Engineers, VDI. There have been even greater successes with the prices of photovoltaic modules, which have fallen by 90% in the last 10 years. Silicon-based photovoltaic cells have now been developed to such an extent that they are reaching their efficiency limits, with their theoretical maximum efficiency at 33%. Much hope is therefore placed on the material class of metal halide perovskites. Solar cells based on this material quickly achieved efficiencies comparable to commercial silicon solar cells after their discovery. Additionally, perovskite solar cells have other decisive advantages. The manufacturing and energy costs are low compared to established silicon technology because they can be produced using cost-effective coating processes. This also allows the production of multi-layered solar cells. Tandem cells, where one layer captures photons with high energy and the other captures those with low energy, theoretically achieve efficiencies of up to 45%. A research team at the Fraunhofer Institute for Solar Energy Systems ISE has shown that triple solar cells consisting of perovskite silicon subcells are also very promising. Classic silicon solar cells have an open circuit voltage between 0.7 and 0.8 volts. If we can measure a voltage of over 2.8 volts with the perovskite silicon solar cell, we can truly infer enormous electricity generation potential, says Dr. Julian Borcher, Group Leader for Perovskite Silicon Technologies at Fraunhofer ISE and the University of Freiburg. This is a record for this type of solar cell and shows that photovoltaics can still expect a lot from the combination of perovskite and silicon. Wind turbines are also evolving. Most noticeable is their increasing size. Current turbines are up to 160 meters tall and achieve outputs of 5 megawatts onshore and 15 megawatts offshore, a multiple of the initial capacity. Efforts are also being made to improve these turbines, with completely new designs being experimented with. The Dutch company Touchwind, for example, has designed an offshore wind turbine equipped with a single 200-meter-long blade. The system is expected to cost only about a third of the known three-bladed standard variants, while providing the same performance. Vortex bladeless systems even operate without rotors. The cylindrical construction uses wind vibrations to generate energy. Research is also being conducted on future technologies such as superconducting generators. These only come into play for sizes well over 10 megawatts, but then open up a whole new field for drastically improved designs, which in turn lead to further cost reductions or a broader range of applications. We hope you enjoyed this article readout from our latest TQ magazine. To access the full magazine for free, just check out the show notes. Thank you for listening and stay tuned for more insights in our next episode.